Okay, I think we can just go ahead and get started. Timo?
Yeah, I think so. I think it's a good idea. So I assume everyone can see my screen, but today we will
Yeah.
be giving, yes,
Yes.
sorry, I didn't confirm before I moved on. Cool. So today we'll be giving a product demo of how you can query logs and metrics in tandem. So this, for context, has been a highly requested feature from our users. So we're appreciative of your energy and time in joining us today. We welcome any feedback through chat. If it's during the call, if you want to come off mute and have a more interactive discussion on a more pressing topic, we could pause the demo or any of the slides and do so. And if there's any questions you want to reserve till the end, we have left some time for Q&A. So feel free to take either approach. And then for the questions that are posted in the chat, we'll have somebody monitoring those. Hopefully we can get those at the time. If not, we'll reserve those to the end as well. So to properly introduce myself, my name is Tay Marie, and my role as a sales manager here at Greptime at the moment is very dynamic. So I'm handling many of the traditional sales responsibilities and also very focused on bringing awareness, networking, and learning from experts to familiarize ourselves with our future potential customers. So for those of you that are unfamiliar with Greptime, GreptimeDB can be the database layer for the data source that you see on my screen. So sensors and QTT, Prometheus, to name a few, and can fit or it can fit into any application for dashboarding, alerting, monitoring, and anomaly detection. And as a direct preview of today's demo, I will be showing you how to leverage a unified event database. So this is what we're aiming to do, provide you with a great option to query logs and metrics at the same time using one standard language. And most of you that have joined today, and those of you that are watching, you're probably using these technologies. So you're familiar with some, if not all of these that you're currently seeing on the screen. And our goal is to keep the learning curve to a minimum so you can use what you already know. So that's a little bit about myself and what we're trying to accomplish today. And I'll pass it over to my colleague, Rihal, to get started with this piece.
Hello, I'm Reihang, the engineer from Greptime. And welcome to today's GreptimeDB 0.9 online meetup. Today we will mainly introduce and demonstrate the log engine. First, let me introduce our 0.9 version. In the past months, we have merged a large number of commits, more than dozens more than the last time. In addition, 5 community individuals have contributed 11 code contributions. We also nominated 3 new external committers between 0.8 and 0.9 version, and thank all contributors for their submissions. In this session, we mainly introduce our new log engine. First of all, why do we need a log engine as a time series database? Generally, people directly equate time series data with metrics. But in fact, logs are also a very important part of monitoring scenarios. Log data is usually unstructured or semi-structured data, including common text, timestamps, error messages, even description, etc. And it may also be debug logs or info logs written casually while writing code. Our log engine is designed to solve this problem. The newly offered log engine aims to solve problems in monitoring and observability scenarios. Metrics are often insufficient and analyzed, and logs are not fully utilized in reality. Log contains very rich information, which makes them very complex. As a record of event, logs contains a large amount of unstructured information, which requires a more complex search mechanism than metrics to extract meaningful information to achieve the goal of data insight. We simplify the root cause analysis process by centralizing all monitorable logs and metrics in GreptimeDB for viewing from a single location with various perspectives. To achieve this goal, we introduced the pipeline log conversion and processing model in this version, which allows associating logs and metrics for analysis in the same view. We also provide full text indexes and search capabilities that support common index method and allow users to search using various lexical expressions to improve search efficiency and flexibility. The demo session would show how to associate log and metrics for analyze in the same view. Here is the main changes in our new release. In addition to the log pipeline and full text search I mentioned earlier, we have also made some enhancement to existing features. You can find a complete changelog in our official website, and we have some other exciting changes that I didn't list here. Feel free to check out the details of what interested you. Next, I'll hand it over to my colleague Yi Song to introduce the principle and usage of pipeline.
Thank you, Rehan. I'll take from here to introduce the pipeline engine. Firstly, what is a pipeline engine and why do we need one? It's a rule engine for text parse, process, and type conversion that we built from ground up. It uses YAML config to define rules like the one on the right. We'll talk about this definition later in detail. The reason why we need such an engine is because normal log that comes into our databases is basically long strings. The strings themselves are unstructured and database cannot identify their data semantics and type infos. So if we look at how the logs are produced, in most cases, it's our middleware in the application that is in charge of printing the logs. And they print the logs with certain formats, like always start with a timestamp, followed by a log level, etc. And the format within the log is structured, but when the log as a whole is printed as a string, it becomes unrecognizable for our database to understand the information come along with the format, just like the timestamp and log level there. And in this scenario, a rule engine that extracts these timestamps and log levels will come in handy. By extracting from row strings and attaching type infos to the field, we gain benefits. We'll talk about the compression ratio later. And so now we have a look at the life cycle of using pipelines. First, we need to define a pipeline rule like the one on the previous page and upload it to the database. The pipeline rule will be compiled and saved in the memory of our database in Pipeline Manager. And then we can ingest the log data using the HTTP API with the pipeline name we uploaded earlier to reference which pipeline we'd like to use. The import log data will be handled by the pipeline and be processed into structured data as we define the pipeline config, as we defined in the pipeline config, and finally be ingested into the database with structured information. We'll go through a detailed example of how input log is processed and get ingested. Let's take a look at our pipeline definition. As you can see on the right, the pipeline is divided into two parts, processes and transform. And the first part, which is processes, defines how we wish to pass and process the data, including splitting, replacing, etc. The second part is transform, where we rename the field, convert them into data types supported by our database, and specify indexes. And here we have a few processor examples, like the date processor can take an input string and pass it into a timestamp, and it also supports time zone while passing. And there are a lot of processors on the list and more on our document website, and you can check it out if you are interested. And the transform part does three things: renaming fields, type conversion, and specifying index that are persisted into our database. For instance, we can see the second field from the bottom on the right is log. We use a comma followed by a field name content, which means we want the log field to be renamed into the content field in our database. And also we add a full text index here, and later we'll see how it is translated into a create tables option and persisted into database. And now let's look at the pipeline config example we showed to you earlier to see how we actually use pipelines to process normal strings into structured data. We can see the raw input string here is pretty clearly formatted, starting with our timestamp, following by 2 IDs, and then log level, log name, followed by a column, and finally the actual log content. Take a closer look at our processor definition. We see it processed the data in 3 steps. Firstly, gsub, replacing 2 or more spaces with only 1 space using regex expression. Then we use dissect processor to splitting the whole sentence into different variables, which we can use later. And finally, a date processor to convert TS field into a timestamp using given format string and time zone. Into the transform part, we convert the variables extracted earlier into a concrete data type like int32 for their for sure numeric fields. Log and log level remain string, and we rename log to content field in the third transform and specify full text index here. And finally, TS field as a time index, as our database always requires a time index in the table. After the conversion, it automatically detects and creates the table in database. The generated created table circle are listed here, and you can see it's clearly inferred from our pipeline definition, like the content field with full text index. And unlike normal create table circle, we add append mode equals true here. So it's only insertion and no override. In most cases, we don't want our log overwritten. We can run a circle query here from logs table to see that they are actually divided into different columns and preserved as we wish. Okay, so we've just go through the entire life cycle of pipeline engine. Now let's talk about the benefits. Why pipeline engine, or more directly, comparing to storing the row string, what benefits does the pipeline engine bring? Firstly, query efficiency. In row string, even if we know for sure there is a log level field, we cannot use the field to filter because the string as a whole is unstructured and the database cannot refer to the part of it. By extracting it into separate columns, we now have the ability to explicitly specify the log level we want or don't want in query. And it's already way better than like clauses in circle. Moreover, we can build index upon fields to further speed up the query. And as we can see here, the actually log content part is rather small compared to the original string. We eliminate the structured part first, and then full text index, and then add a full text index upon the actual log content, reducing the range we want to query, and at the same time improves query efficiency in string matching. And secondly, compression ratio. String formats have its limitations when it comes to compression. For example, a 30 megabyte file full of logs can be compressed into a 2.3 megabytes gzip file, and that's it. You basically cannot make it any smaller. By passing the log lines into structured typed data, we apply some column compression techniques to take a step further in compression and get a final file of only 1.03 megabytes. And it is 55 more space efficient. And that's the pipeline engine. You can find more information on our document website. Now let's welcome Zhenqi to introduce full text index.
I will introduce the food test index in version 0.9. The main feature of version 0.9 is the log engine, and food test index actually appears as its query ability, bringing food test search capabilities to GreptimeDB. The following are the specified contents. In version 0.9, we can create a food test index for test columns when creating a new table, and the test supports Chinese and English analyzers. When searching, we use SQL functions to perform food test searches on test columns. Currently, the supported search capability is turn query. For example, we can use master, return, Boolean operations, etc. to perform searching, which will be described in detail later. In future versions, we will add the following features. Adding food test index to existing tables, and enriching more queries, such as fuzzy search. For more information, please refer to the documents below. Next page, please. Here is an introduction to food test index architecture. GreptimeDB's architecture is divided into front-end and data node. Front-end supports multiple protocols, including SQL, gRPC, and remote write, and can write rows to data node through these protocols. The example is a text column containing HTTP code writing to data node. Data node contains many regions, and when flash is executed, data is written to SST table files. At the same time, the SST file will build an index file, which includes the food test index introduction introduced in this version, and the inverted index introduced in previous versions. During the reading process, it can be seen that when front-end needs to read through some protocols, such as matching texts like 41 or 44 here, and sends to data node. The region can query rows IDs contain 41 or 44 in the food test index, and then filter according to the information, and returning the rows that met the conditions. This can reduce the number of rows scanned. Next, please. Okay, here I will introduce the usage of food test index. First, let's talk about the construction of food test index. As mentioned earlier, our version supports specify food test index on new creating table through column options. The first example shows how to specify a food test index for the column using default options. Simply add the food test keyword after a string type column to build food test index for the column. Additionally, different configurations can be specified for building food test index. Currently, we support two configurations, analyzer and case sensitive. The analyzer can be used to specify English or Chinese word analyzer for food test index. And case sensitive is used to specify whether to be case sensitive, which defaults to be case insensitive. Next, please. After the index building is introduced, I will next introduce how to perform a search. We can perform a food test search on food test index columns through the matches function. The example provided here is where followed by a matches function, which has two parameters. The first parameter is specified as message, which is a column name in the logs table. And this column is specified to build a food test index using the food test option in the create table statement. Currently, we recommend performing searches only on full text index columns. The second parameter is the query string, where the sample is error or failed, which means you want to query for texts that contains either error or failed. I will later provide a detailed explanation to the syntax and meaning of query statements. Next page. First of all, if you are familiar with Lucent, this should be relatively easy to understand. The simplest query type is simpleton. It refers to a search for words specified, separated by space. Here is an example, meaning the sentence that contains either Barack or Obama. In the following example, you can see that both sentences matches this condition. Next, please. Negative turn. Negative sign is added in front of a word to indicate matching the text that does not contain the word. For example, because the first sentence contains the word Obama is excluded, while the second sentence does not contain the word. It matches successfully. Next. The third part is must turn, represented by a plus sign in front of a word, which must be included in the search. In this example, the words Barack and Obama must be included. And as can be seen from the example below, previous page, please. The sample text below, only the first sensitive meets the requirements because the second sensitive does not have the word Obama. Next. We also support Boolean operations such as and, or, etc. For example, in the first example below, the query statement Barack and Obama represent text containing Barack and Obama. Okay, the next is here I will introduce the phrase turns, which should match several words as a whole. Since these words may contain space, if you want to match them as a whole, you can use cross to enclose them. In the given text, only the first sentence contains the phrase Barack Obama as a whole, so only it satisfies the condition. There are all query statements, and for more detailed information, you can refer to our documentation. Next. Yeah, that's all for my introduction. Let's invite Wei Hang to demonstrate.
Thank you, Zhenchi. We have already detailed the two important new components. Briefly, pipelines are on the right path and full text index is on the right query path. Next, I will use an example to show you how GreptimeDB works in a completely observability scenarios with logs and metrics. We built a simple demo. Let me first introduce the demo, which uses Docker Compose and starts the following components. First, there will be an Nginx acting as a proxy gateway between a mock server and mock client. Then the Python client will send a request to Nginx, which will forward the request to the server later. At the same time, both Nginx and the server are configured with corresponding logger recording and Prometheus metrics collection, which will report the data to GreptimeDB. Next, there are three collecting methods. First, we have a vector responsible for collecting Nginx logs, which are collected from Nginx and reported to GreptimeDB. Then the Flask server directly writes the logs to GreptimeDB through HTTP requests. In addition, we have a Prometheus that collects data from Nginx exporter and write it to GreptimeDB. These are the three main write paths. This is a simple relationship between the 5 components and will be converted later in the demo. Among these five components, a total of 3 tables are generated. The Nginx access log is a log table collected and converted by vector and pipeline from Nginx. The engine statistics is a log table based on previous access log, which is aggregated in real time through the flow released in version 0.8. And the important data in the log table is continuous aggregated to generate the statistics table. The third one is the data log directly write from Python server to GreptimeDB, which will be placed in the server log and converted through the pipeline. We will build a complete Grafana dashboard based on 3 tables mentioned earlier, and the following demo will be displayed on the Grafana panel. Before the demonstration, we will briefly introduce several aspects of the feature involved. The first is pipeline, which function is to pass and transform Nginx log, converting from log string directly output to standard output by Nginx. Through parsing and granular segmentation to generate the table structure we need, this part of work is done through pipeline. Secondly, we will also show how to extract platform information from the user agent through pipeline. The second part of flow mining involves 2 aggregation panels, and we can learn more about later during the practical demonstration. We also present the full text later in the end. Okay, next let's switch to Grafana. This is Grafana. Yes, here. This is a Grafana we have configured. We will provide the full link to this Grafana later, which is a complete Docker Compose project. You can run this project locally within 1 click. And then you can see the same dashboard and data like this. The dashboard is continuous writing data and the ratio is figure. We show for 30 minutes of data here. Let's take a look of each panel one by one. Here is the total amount of data. For example, we process 2,600 lines of data here. This is a interesting example that shows the pipeline data extraction capabilities. Here, we process the requests that have a user agent field, like this. This field, for example, has a tool chain in the front, a platform behind it, and then some detailed information behind that. We can simply aggregate all of them and display. And this is each of the colored boxes, like the red one or the green one. However, this is a bit mess, and we may also want to know which platform the request is sent from. Therefore, I would like to perform specific aggregation on the platform. Like this is a Macintosh. The platform in the user agent to display the tree map panel is what we see now. We extract the part of this big pattern user agent through the pipeline and display it here. Finally, a 2-layered tree map diagram is formed. Let's see how to write this query. In fact, the query is much simpler than expected because the corresponding operations have been processed through the pipeline during writing to GreptimeDB. So when query, we only need to simply extract the columns we want and display them in the tree map. Above metrics are off for the overall perspective of Nginx. Next, let's go back to our familiar time series part. Here. This time series looks ordinary, but in fact, it is to demo downsampling through flow. In this panel, only the payload size than 550 are counted. And the previous chart were configured using SQL, while the next two were written in PromQL. Let's check it out. Yes, now we are working with PromQL. The GreptimeDB data source, you are not limited to a specific language when configure a dashboard. You can choose the one that suits you best or the one that you are most familiar with. Next, look at the chart in the lower left corner. The latency top 10. This one. It indicates that these are the 10 slowest logs on the server side. From this chart, you can see in real time that 10 slowest requests in my entire system within the past 30 minutes. Other informations like who initiated them and what their trace IDs are, we can then use these trace IDs to conduct further investigations and analyze the root cause of these issues. We may find an anomaly and need to analyze specific log in more detail. That is the next two charts. Here, this the right-hand side Q1. This chart shows the newest 15 logs collected from Nginx. The log can be expanded here. Like I click one, and you can see other fields, such as the method, which interface, and which trace IDs. The trace IDs is associated with the trace ID in the server side. Okay, then let's analyze the reason why the 10 slowest logs were generated. For example, we can click which tenant is requesting, which leads to such a slow response time. This will help us find the most valuable information. Let's zoom into this dashboard and take a closer look. Oh, okay, let's do it in practice. For example, we just copy a user or tenant, like here. And that we want to search for, we want to search silver. And found that 10 slowest requests. For example, if we only read silver and refresh, okay, there are 10 slowest logs associated with silver only. But in some cases, we might know, for example, we know some queries are for offline analyze, and we don't include them. We can add more conditions like Zhenchi introduced late above. For example, we have a master word silver and a negative word and connected it with N and also negative dog watch. And then by applying this condition, we can search whatever we want from our dashboard, and we can find the exact slowest 10 that may cause the problem. Okay, that's it for this demo. This is a process of the entire demo, and now let's move on to the QA session and handle to Tay.
Yeah, so as Rehan said, are there any questions that you'd like to discuss live? If you would like to discuss it offline, you could also reach out to me as well over LinkedIn or by email, tay@greptime.com. But we'd be happy to answer any questions if anyone has any at this time. All right, I think we have a question in the chat. Is log pipeline ingestion real time or micro batch?
I think Yisong, you can give an answer. It's a great question.
And the pipeline ingestion itself is in real time. And every request received by the database server will be processed immediately. However, you can batch your request request the database with multiple lines, and the pipeline ingestion can deal with multiple lines at the same time.
Yeah, I think it's real time for every batch because you can send a batch of requests to the GreptimeDB pipeline.
Yeah. Any other questions? Can I write my own log processors, or the only standard ones showed in the demo exist today? Or only the standard ones showed in the demo, showed in the demo exist today?
Oh, I think it's a great question. We already provide some standard processors that, as the Yisong mentioned in the sliders, just like the date or the regex like that. But we don't provide some the custom processor right now. But we will provide a feature to write your custom processors in the future, in the next plan, or I think it will not be in the next release, but we will consider it.
Cool. Anything else? Feel free to click on the raise hand, come off mute, or post in the chat.
Hello. I'm wondering where we can find the repo for the demo that was showed today.
Oh,
Okay.
Rehan, you can give the link.
Oh, the repo is here under Greptime team organization. We have a demo scene repository, and the demo I just demonstrate is this one, Nginx log metrics. And this is a .compose project. You can enter this directory and write .compose app, and you will see the same things like as this screenshot. Yes. Here we have a command and instructions on how to run it.
Okay, I send the link to the chat box. You can check it out. Thank you. Okay, so
Yeah.
I think there's no more questions.
Yeah, I think we can conclude here. Again, thank you everybody for taking the time. Really
Thank you.
appreciate
Thank
it
you,
today.
everybody.
Yeah, we appreciate the questions, and feel free to reach out after the call if there's anything else.
Okay, good evening.
Okay.